Okay, so in this video, we're going to look at the three exponent laws. There's the multiply law, the divide law, and the power rule. So I've got a brief description here. Multiply law, if the bases are like, keep the base and add the exponents. Divide law, bases are like, keep the base and subtract the exponents. And the power rule, if an exponent is raised to another exponent, keep the base and multiply the exponents. So we're going to take a look at examples of each ones. We're going to look at the multiply law first. So again, those look like this. So if you have 2 to the exponent 3, and it's multiplying 2 to the exponent 4, this would be a perfect example for the multiply law. See, the bases are the same. They're both base 2. So you want to keep that base, and you want to add the exponents. Now, we can prove that that's actually correct, because we know 2 to the 3 is 2 times itself 3 times. And 2 to the 4 would be 2 times itself 4 times. And if I add these up, I've got 7 altogether, which proves the law right there. So again, if you have like 3 to the 4 times just 3, now the bases are the same. Now you don't want to go 3 times 3. That wouldn't be correct because you would totally be ignoring the exponent 4. But you're going to keep that base. Now, for 3, just because we don't see an exponent doesn't mean there isn't one there. A 1 is understood. So you're actually going 4 plus 1 to give you 3 to the 5. And you don't know the value of the base all the time, so that's where your variables come in. So you have x to the 5 times x to the 3. Because they're both base x, you're going to keep that x, and you're going to add the 5 and the 3. The key is the bases have to be the same. So when we get into things like this where we have multiple bases, so let's look at this one. So we got two variables, x and y. Well, the base x can only apply the multiply law of the other base x. So same base, we're going to add the exponents 2 and 9. Likewise with the y, same base, and you're going to add the exponents 5 and 3. You want to be careful if you run into a situation like this. So we'll go x3, y6 times x, y, and then z. So we got 3 variables. Again, you're going to connect the like bases. So that'd be 3 and 1 is 4 for the x's. And you got the y's, 6 and 1 is 7. Now there was only a z here. There was no other z in the other term. So the z just stays as is. If you have coefficients in front of your bases that are unknown, so what I'm talking about is stuff like this. So 5x to the 6 times 3x to the 5. So there's nothing stopping us from multiplying 5 and 3. Now, for the base x, we don't know what the value of it is, so we want to simplify it a bit, and that's where our exponent laws come in. Just going to add 6 and 5 is 11, and then whenever we know the value of x, we can continue. So we'll look at the division rule now. It's pretty much opposite the multiply law. So if you have 6 to the 3 divided by 6, so it's the same base. So this one says keep the base and subtract the exponents. So I'm going to go 3 subtract this 1. That's understood there. So it would be 6 to the 2. Now we can prove that also because 6 to the 3 is 6 times itself 3 times over 6. And we can see these two would cancel, and yes, we get the same thing, 6 to the 2. So again, likewise, if you don't know the base, so if you have x to the 9 divided by x to the 3, keep that base and subtract the top one, subtract the bottom one, 9 subtract 3. Likewise, if you have multiple variables, so again, you're going to connect the ones that have the same base. So in this case here, we're dividing, so we'll connect those x's, we'll keep the base, and go 9 subtract 2 is 7. And we got the y, so we're going to keep that y and go 6 subtract 4, which is 2. And if you have coefficients involved, same idea. So 28x to the 5 divided by 4x to the 3. Nothing stopping us from going 28 divided by 4, which is 7. And x5 divided by x3 would be x2. And the last one I like to call the power rule. So it's when you have an exponent raised to an exponent. So it looks like this, 3 to the 5 to the exponent 2. So we have this exponent to an exponent. So the rule says you're going to keep that base and multiply the exponents, not add or subtract them. Now we can prove that also, because 3 to the 5 squared means 3 to the 5 times itself twice. Well, that's just the multiply law. Same base, add 5 and 5 is 10. So again, if you don't know the value of the base, same idea. You got exponent, exponent. You're going to keep that base x and go 5 times 4 is 20. Now, where you want to be careful is when you have multiple parts to your term. So here I got a coefficient 2, x to the 5, y to the 2, and I'm going to raise the whole thing to the 3. So in this case, that exponent 3 is going to multiply with all the exponents. But you got to be careful, the 2 also has an exponent 1, which is easy to miss until you get used to it a bit. So you're going to keep that base and go 1 times 3 is 3. Keep the x base, 5 times 3 is 15. Keep the y base, 2 times 3 is 6. And also, when you have the chance, you can evaluate the ones where you know the base. So in this case here, 2 to the 3, I can evaluate that as 8. And then I can simplify it even further. So those are the 3 exponent laws.